it's raining, so I guess I'm going to make a video instead. We are going to talk today in lesson 111 about multiplying polynomials. This is going to be important, and it's also somewhat difficult, so make sure you're paying close attention and taking good notes. I'll see you guys on the other side.
Alright, so in lesson 11, we're going to be multiplying polynomials. We've already practiced adding and subtracting, and we've seen some of this information that's going to come up in multiplying when we were working with exponents a few lessons back. So our learning target is simply that we can multiply polynomials. Remember that polynomials are simply expressions that have multiple terms. And sometimes we can look at monomials, which is where you just have the one term, but most of the time it's going to have lots of terms. So let's go ahead and jump into the simplest case. The simplest case for polynomial multiplication is when you actually just have two monomials, meaning one term. For example, if you have something like this where you have 5x squared times negative 2x cubed. We've already seen problems similar to this back when we were doing multiplication with exponents or simplifying expressions with exponents. But just as a quick refresher for you, what you would do here is you would multiply your coefficients. Remember, your coefficient is the number that's being multiplied by your variable. So in this case, it would be 5 times negative 2, which is negative 10. And then you would multiply your variables. X squared times x to the third, we're going to add those exponents, and 2 plus 3 is 5. So my answer is negative 10 times x to the fifth, and that's done. The next step up, if you're trying to get more complex, is multiplying a monomial times something with more terms, either a binomial or something with 3 or more terms. So an example of that would be something like this. We've got negative 3x, there's my monomial, and I'm multiplying it by this trinomial, 4x squared minus x plus 10. To do this, what we're going to do is we are going to distribute that negative 3x throughout the parentheses. It's very important that you realize that you're taking that negative 3x and multiplying it by not just the first term, not just the second term, but by every term inside of those parentheses. So I'm going to say negative 3x times 4x squared, negative 3x times negative x, and negative 3x times 10. So when you're doing that multiplication, again, you're going to multiply the coefficients. Negative 3 times 4 is negative 12. And then multiply your variables. X times x squared gives me x cubed, because remember, there's a little understood 1 on that variable, so my exponent is 1 on both of those variables. All right, now I've got negative 3x minus x. Negative 3 times a negative, there's a little understood 1 there. Negative 3 times negative 1 is positive 3. And then x to the first times x to the first, we would add those and you get x squared. Okay? And the last one is negative 3x times 10. I'm going to multiply my coefficient by that constant. Negative 3 times 10 is negative 30, and then my x gets multiplied as well. So that is multiplying a monomial, a single term, by multiple terms inside of parentheses. The next step is the one that you're going to see the most often, and that is when we have a binomial, meaning an expression with two terms, multiplied by another binomial. There's actually several ways that you can approach this problem, and we're going to show you all of them. The first is horizontal, and this is going to be really just very similar to what you're doing up here. It's basically distribution. So we know that when we're multiplying by something in parentheses, we have to multiply by everything inside parentheses. What you're going to do with distribution is you're going to multiply each piece of this binomial by everything inside of this binomial. So here's what I mean by that. I'm going to take this x and multiply it by x. Well, x to the first times x to the first is x squared. Then I'm going to multiply this x by my 2. so that I've now multiplied this x by everything inside of that second expression. And I've got x squared plus 2x. Then I'm going to take my 3 and multiply it by everything inside of this binomial. So 3 times x will be positive 3x, and 3 times 2 will be positive 6. And your last step when using this method is going to be to combine your like terms. Well, x squared doesn't have any like terms. There's no other variables that have an x with an exponent of 2, so that means x squared gets to stay put. 2x, positive 2x, and positive 3x are like terms. They have the same variable and they both have an exponent of 1. So those get to be combined, and 2x plus 3x is 5x, and then my 6 is the only constant. So it goes here. All right, I'm going to take this same problem and show you how to do it vertically. This is going to be more like the multiplication that you probably learned in elementary school when you were multiplying larger numbers, like 2 and 3 digit numbers. And it's kind of the same thing, but it's just a different way of visualizing it. So back when you were first learning to multiply, you would start with your ones place and you would multiply it by everything on the number on top. So let's do that same thing here. I'm going to say 2 times 3 is 6, and 2 times x is 2x. This is a positive 6, so I'm going to put a plus in between there. Then, back when you were multiplying as a kid in elementary school, you would have gone up to the next place value and multiplied it by everything. You probably would have put a 0 here or something as a placeholder. And you can still do that here, but it's not really necessary. So what you're going to do is you're going to say, okay, x times 3 is 3x, and x times x is x squared. And again, that's a positive 3x, so I'm going to put a plus. And then remember back in elementary school, what you would have done next is you would have added those two lines. Well, if you kind of skipped a space here like I did, now you've got all your like terms kind of lined up, which is a happy coincidence. And you can say, I've got a 6, 2x and 3x are like terms, so I can say those added together are 5x. And then I've got x squared that has no like terms. Notice it's the exact same answer as we got over here. If you're looking up extra help online about how to multiply binomials, you're likely to see this little acronym, FOIL. We don't want you to focus on this method too much because it really is specific to binomials times binomials, and we prefer either the horizontal or the vertical. But if you happen to see FOIL when you're watching other videos or studying on your own, what that stands for is your F is your first numbers, your O is your outer numbers, I is inner, and then L stands for last. So what that means, it's basically just a way of helping you remember what numbers to multiply. So first means I'm going to take my first numbers and multiply them. X times x is x squared. Outer means I'm going to take the ones on the very ends of the problem, the very first and the very last. That's outer. So x times 2 is 2x. Inner means I'm looking at just the numbers in the middle or the variables in the middle. 3 times x is 3x, and then last means I'm looking at the last value in each binomial. So 3 times 2, that gives me 6. Notice it's the exact same thing as doing the distribution method. It's just a different way of thinking about it. So x squared plus 5x, because again I'm combining those like terms, equals 6. All right, so pick the method you're most comfortable with. When you get into the practice, the last 4 problems or so are multiplying binomials times trinomials. We recommend that you do that using the horizontal method or the vertical method. If you have trouble though, I am going to not multiply, but I'm going to record an extra little video to help you with that. So look for that on the website if you need it. If you don't need it, that's fine too. Have a great day, guys.